Welcome back to the UMRB Drought Dashboard. In this video, we'll define the other drought variables and show how you can view and interpret the data. These variables all use a standard 30-year reference period in the models. By clicking on the map controls, you can see the list of the other variables. First, we'll discuss the soil moisture variables. These are critical for monitoring drought conditions and understanding vegetation and crop health. You can choose from two different models. First, we have SPORT LIS, which is NASA's 3-kilometer resolution depiction of soil moisture in near real time, incorporating many data models. You can also display TopoFire, which assesses the terrain-driven variations in soil moisture based on a higher 250-meter resolution of daily total column soil moisture anomalies. For more detailed information, click the Info button on the right. Next, we have meteorological variables such as precipitation percentiles, precipitation percent of normal, temperature percentiles, or daily maximum temperature. Precipitation percentiles shows how current precipitation compares to a 30-year reference period, indicating whether it's unusually wet or dry for any specific time period. For example, a higher percentile or blue-colored percentile would indicate wetter conditions. A lower percentile would be drier. You can also choose precipitation percent of normal. This is a quick assessment that compares observed precipitation to the historical reference period. For example, the lower the percentage in brown, the drier the conditions have been. The higher, the more precipitation accumulated in a darker blue. Temperature percentiles, or daily maximum temp, compares daily maximum temperatures to the historical reference period. Temperature percentiles are useful for assessing temperature extremes and their potential impacts on ecosystems. For example, the higher the percentile, or the more red an area is, the warmer it's been compared to the historical average. The lower, the cooler it has been. You can also display snow water equivalent, or SWE, which is the snowpack relative to historic norms. This also uses the U.S. Drought Monitor classification system, so the more negative, more red, the lower the snowpack is. The more positive, or blue, the greater the snowpack is relative to the historic norm. You can choose to select basin-wide SWE or direct SNOTEL SWE. Additionally, you can display groundwater and vegetation data. When you display GRACE Groundwater Percentile from NASA, it uses satellite information based on measurements of the changes in the Earth's gravity to understand how much water is stored underground. The data is expressed in percentiles, similar to the meteorological data variables, to show the change over time. For example, a low percentile indicates drier conditions, and a high percentile would indicate wetter conditions. Finally, you can also display vegetation drought information. First, there is the Forest Drought Response Index, FORDRI, that monitors the drought stress in forests. This uses the U.S. Drought Classification Scale as well. Secondly, there is the Vegetation Health Index by NOAA. This scale is different from the rest of the variables in the UMRB dashboard and estimates soil moisture and climate conditions over 7 days as a proxy for vegetation health. If the VHI is below 40, it indicates vegetation stress and potential loss. VHI above 60 suggests more favorable conditions. In conclusion, the UMRB Drought Dashboard offers a comprehensive and user-friendly interface to display and interpret a wide range of drought metrics and variables. By simply clicking on the map controls, you can access detailed data on soil moisture, streamflow, precipitation, temperature, snow, groundwater, and vegetation health. Overall, this is a great tool for understanding and managing drought conditions. Thank you.